This is a very interesting problem. It's based on transformation. Question 3. It says, describe the transformation that will map y equals to 2 minus 3x onto itself. So what do we mean by this? We mean if you translate or dilate or do whatever transformation, it should be the same line. Okay. Try to do this problem, think over it. Okay. And then look into the solution. Now, let's try to attempt it. So let's first think how the line looks like. So we have a line here which says 2 minus 3. So y-intercept, let's say, is 2 and slope is negative 3. So we go down and 1 here. So we get a line kind of, let's say, line like this. Let's say this line is y equals to 2 minus 3x. Correct? Now, how could I transform this? If I do any stretches, then this line may become steeper, right? Or compressions and stretches, this may change, right? Because whenever I do that, then my slope gets multiplied by that factor, and therefore the slope of the line changes. Therefore, doing stretches and compressions may not really help. Well, one could do both. One could do a stretch and a compression and then get the line to the same point. That is one possibility. Yes, it is. Well, how about translation? Translating lines, if I move up and down, its position will change. Critical point to check is x and y intercepts. So if I move left, right, or up and down, my intercepts will change and therefore the line will change. So how should I do? I could do a combination of that. Combination of horizontal and vertical, correct? That will help us to keep the line in the same place. That may work. So there are two approaches to this. You can follow either one of them, correct? So think like this. Vertical stretch and horizontally compressed may give you something, right? Okay, anyway. But what I will prefer is, I will prefer to move a point. Basically what we are doing is, let's say this is our point of y-intercept. We should move it in such a way that even after movement, it falls on the line. So if I do, let's say, like some units here and bring it down, and if it could come back on the same line, in that case, my purpose is achieved. So every point, if I move, let's say, someplace and then bring it down and it comes back to the line, then I'm actually forming the same line. This ratio, moving left and right, left or right, and then up and down, is actually given by the slope, right? So think like this. My slope in this equation is minus 3. That means I have a rise over run, and if I do rise of 3 units minus, that means down 3, and run, that means right 1 unit, then I'm able to achieve this thing, right? So one of the transformations could be translate 3 units down and 1 unit right. So that will give the point back to the line. Is that okay? So that could be one solution. One, I could translate 3 units up, right? 3 units up and 1 unit left, right? Then also I get minus 3 as my slope. So by doing this, we ensure that the points after translating come back to the line itself. Do you see that? So that is the way we are going to translate and get all our points back to the line, right? And then we can do it, correct? So that's a good way of solving this problem. So that is a transformation. So either one of them will serve the purpose. I hope you understand and appreciate it. Thank you.